about changing fractions to decimals. When you change a fraction to a decimal, you are using division. So in order to change the following fractions, we could use our calculator to help us. We could put 47 divided by 1,000 into our calculator and find that it equals 0.047 or 47 thousandths. 59 over 10 put into our calculator is 5 9/10. 7 over 20, if I put that in my calculator, remember, top divided by bottom is 35 hundredths. And if I put 3 over 5, or 3/5, into my calculator, I get 6/10. Those are ways to change a fraction to a decimal. Here's an example of two students trying to do so. One is trying to figure out without a calculator by getting the denominator to be 100, and the other is using their calculator. Both methods are correct. One just takes a little more time. But if we can ever get a fraction to 100, we know exactly how to change that to a decimal, that the decimal there has to be 2 digits after the decimal point. Let's look at some more examples here. How do I change these fractions into decimals? Again, go ahead and use your calculator or try to get the denominator to 100, whichever way is easier for you. So in the first one, 16/25 gives us 64 hundredths. The next one, 5/8, gives us 625 thousandths. For the third one, 322 hundredths is 1 6/10, and 8 over 125 is 64 thousandths. If I needed to get these denominators and did not have a calculator to 100, I would look at the first one, 16/25. Well, to get 25 to 100, I would multiply by 4. That means I would do the same thing to the top number. This would give me 100 in my denominator and 64 in my numerator. That's how I'm sure that it's 64 hundredths, and we've already learned how to write that as a decimal. So if you don't have a calculator, remember, we want to get the denominator as to 100 if at all possible. So here's one without a calculator. How could we find what the decimal equivalence of 2/3 would be? Well, we could use division. Remember, the top number goes inside the box, divided by the denominator. If I do so, I can't take 3 into 2. I have to add my decimal point. Make sure you remember to bring it up top and add a 0. 3 goes into 20 6 times. 3 times 6 is 18. If I subtract, I have 2. I can bring down another 0. Again, I have 20. 6 times 3 is 18, and subtract. Are we noticing a pattern here? This is a repeating decimal. So this would be 0.6 repeating. All right? Doesn't matter how many times I do the division, I'm going to get an answer of 0.666666. It's going to go on and on. It does repeat. When you have repeating decimals, they make patterns. Not every digit will repeat every time. It's possible to have some digits in a number that does not repeat. Look at the second one here, 3.124. The only thing repeating is the 2 and the 4. That's why the line is only above the 2 and the 4, because that is all that will repeat. When you use a calculator, remember, the calculator doesn't have enough room for all the digits, so it may round the last digit on your calculator. So repeating decimals do make a pattern. They do not ever stop. They're always shown by a bar over the numbers that repeat. Let's think about some more. Here are some more fractions that we can change into decimals and determine what is repeating and what is not. Well, 6/9, if I put that in my calculator, I'm going to find that that is 0.6 repeating. Remember, write it exactly like it is in your calculator so we can see. If you put 6 divided by 13 in your calculator, you're going to get the number 0.4615338. And then it starts over with 4, 6 again. That is repeating. All of those digits repeat. 6/15 is 0.4. 6/17 is 0.32. I'm sorry, 352. 9, 4, 1, 1, 7, 6, 5. That's as far as my calculator goes, so I can't go any further than that. The next one is 6/21. My calculator says 0.2857114, and then I start over with 28 again, so that is repeating. And 666/1000 is 0.666. So which of these fractions have repeating decimals? Well, you can see that 6/9 does, and 6/13 does, and 6/21 does. Which ones do not? Well, we're pretty sure 6/15 doesn't. We can see that that terminated. And we can see that 666 terminates. The one I'm not sure about is 6/17. Since my calculator cannot hold as many digits as this possibly could go to, I am not 100% sure. The only way I would be able to do this is long division. I would need to write that out and keep dividing it until I either come to a repeating decimal or a terminating one. So now when you change a fraction to a decimal, you can see top divided by bottom. Putting it in your calculator, you can determine if it is repeating or terminating. Now you have a chart in your book that we need to complete. You need to stop the video now and complete the chart. That is changing all of these fractions into decimals. You could start by doing the ones that you already know. You know whenever the numerator is a 0, that is going to equal 0. There's nothing else that it can. So we could go across and fill these all in to be 0. We also know what 1/2 is. We know that 1/2 is 0.5. So we could fill in all the halves at 0.5. Go ahead and go finish this and see what patterns you come up with. Remember, you want to do numerator divided by denominator when you're putting it into your calculator. Now, I hope you've done this by now because here is the results. You can see by this chart that the ones that have the repeating decimals have a line above the numbers that repeat. None of the other ones do. Now take a look at this chart because we're going to have to use it to find some patterns. The first question that is asked on your page next is number 7. Which columns contain fractions equivalent to repeating decimals? Well, if you look up and down, you can see anything with a 3, the 6, the denominator of 7, or the denominator of 9 all have repeating decimals. So those would be the ones that I would write on my sheet. 3, 6, 7, and 9. Those are the columns with repeating. What are some patterns that we see when we look at the chart? Well, there's many patterns here. We could look at the row with the 5s. We can see that the 5s always increase by 0.2. You could look at the rows with the 2s. The 2s always, I'm sorry, not the row, the column with the 2 always increases by 0.5. Or you can look at the row with the numerator as 0. It's always going to equal 0. Those are patterns that we see. Write down 2 patterns that you see or use the ones that I gave to you. Either is fine. Just make sure you fill out something in your yellow book. Well, that's all for changing decimals and fractions. Go ahead and give it a try on your homework. If you have any questions, let me know.